We're going to deal with some functions here, so this should be somewhat familiar to most of you, but more specifically our function notation. So first of all, before we deal with functions, we need to know what a relation is. And a relation is any relationship between two variables, okay, just any one whatsoever. So all functions are relations, but not all relations are functions. That's the thing. So there's different ways we can represent a relation, and I got a few shown here. So you got the exact same data throughout this whole thing. It could just be listed as a list, right? They just list them out as ordered pairs, 1, 4, 3, 2, so on and so forth. We just list them out. It could be listed in a table. It's another way to show a relation. We could take that table and turn it into a graph as well. It's another way to show the relation. And lastly, you might also see it as what we call a mapping, where they kind of have, your x's in an oval, and they map it to all the different y's, okay, all kinds of different things. All these are just different ways to write a relation. Well, when we talk specifically about a function, it's a relation, but each input can only have one output. Each input has exactly one output. So let's just decide. I got three basically tables here. Let's decide which one of these are inputs and which of these are not, or which of these are functions and which are not functions. Okay, well, the inputs are what? Your x values, right? That's what it is for a graph. Your outputs are the y's. It's kind of your independent, dependent type of thing. So if I look over here, 1, it has what? 1 output. Perfect. Here's my input. It has 1 output. Good. The 3, it has 1 output. Good. This 4, it has 1 output. Perfect. That is a function, right? Each input has 1 output. What about E? Looking at the second one. A lot of people are like, oh, it doesn't look like a function because they're all going to 2, but think about this. 1, that's an input. Does it have exactly 1 output? Yes, it's got 1 output. What about 2? Yes, it's got 1 output. What about 3? Yes, it's got 1 output. What about 4? Yes, it's got exactly 1 output. So that is also a function. It doesn't matter if they all have the same output, but each input can only have 1 output. Well, then when you get to F, just by looking at 1, it has 2 outputs. So this is not a function. So to be a function, each input can only have 1 output, exactly 1 output. And if it's in a graph, we have this nice little test called the vertical line test, right? Because if you think about it, all your x's can only have 1 y. So for example, over at A. So my x value of 2 has 1 y of 2. So if I draw a vertical line right there, boom, it only goes through my graph 1 time. So my vertical line test basically means I can draw a vertical line everywhere on the graph, and it can only go through my graph once. Okay, so if I drew a line right here, it went through the graph once. Right here, it went through the graph once. It went through the graph once. Right? So for example, my x value of 0 has a y value of 3. It has 1 output. Okay? So if I look at, so this would be a function, right? As long as I draw a vertical line anywhere and it goes through the graph once, it's a function. Whereas B, if I draw a line right here, that just went through my graph twice. So the input of 2 has an output of 2 and an output of 4. So that is not a function. And lastly, when it's a discrete graph, I just draw through the dots. So right here, vertical line, vertical line, vertical line, vertical line. Every vertical line only goes through 1 time, right? Went through once here, went through once there. So this is actually a function. Looks kind of goofy, but as long as the dots don't line up. Let's just say for my 1, I put another dot right here. Would that be a function? No, because then I would go through there, and that would not be a function. Okay, so you just have to be careful with that. Get that vertical line test. All right, function notation. We write functions with f of x, or something of x, or something of something. And all this really means is we're just calling this function f. F is the name. And what's inside of there is basically like what's it's made up of. It's like f in terms of x. So f is the name, and it's in terms of x in this case. And all it really does, it kind of just replaces y if you think about our equations of lines and parabolas and things like that. So really, instead of writing y, we're just writing f of x. That's really all we're doing in a way. Okay, or I mean different variables, but more specifically dealing with a coordinate plane. So if I look over here, I got a function f, and it's made up of x's, okay? And here's my function. It's 3x plus 2 over x minus 4. And if I look at my first example, I want to find the function's value when x is 3. Right? That's what that 3 there means. So what do you think we do with that 3? Well, we just take it and we plug it in to every time there's an x into that function. So f of 3 would be 3 times, well, we're plugging in 3 for x, plus 2. I like to put, every time I plug into a variable, I always put it in parentheses, over, well, here I don't need to, but 3 minus 4. Okay, so let's simplify that. So up top, I really have 9 plus 2, which is 11. And on bottom, I have 3 minus 4, which is negative 1. So I really got negative 11. So I would say as an answer, the function when x is 3, it equals negative 11. And we're going to talk about that as an ordered pair in just a second. Well, what do you think you would do with 5? Same exact thing. You'd plug it in for x. So I'll just write it out. I won't actually do it, but I'd go 3 times 5 plus 2 over 5 minus 4. And I do the same thing. So I get 15 plus 2, which is 17 over 1. So I get 17. So I'd say f of 5 is 17. So I won't do this last one, but let's say I wanted to write these guys as ordered pairs. Well, this is how I do it. So if I think about what f of 3 equals negative 11. Well, think about its ordered pairs in x, y, right? Well, what's the x? That's our 3, right? Because we said f of x. Well, then what's the y? Well, we said the y just really got taken place of the f of x. So it's really y equals negative 11. So that would be my ordered pair there. So knowing that, could I write an ordered pair really quickly for f of 5? Yeah, so if f of 5 equals 17, its ordered pair would be 5, 17. Just like that. Okay, so function is just a funky way of writing an equation, really, just in function form. Well, here's where it gets a little bit trickier. Now I'm bringing in a variable. It's nice and easy when it's f of n, because all I'm really doing is what? Replacing x with n. So I just put an n instead. So I would just say 3n plus 2 over n minus 4, and then I'm done. I wouldn't have to do it. I mean, I should try to simplify, but nothing factors there, so I'm done. Here's where it gets a little bit trickier. I got x plus 1 now. Okay, well, the same concept works. All I'm doing is, it's saying it's in terms of x, so I'm going to replace all x's with what? An x plus 1. So I'm going to plug that in for that x up top, and I'm going to plug it in for the x down low. So I'm going to say 3 times, well, I'm going to replace it with x plus 1. Put it in parentheses. Over, same thing. I might put this in parentheses just in case. So x plus 1, I replace that with x minus 4. Well, let's simplify. So f of x plus 1 equals, so I got to distribute here, 3x plus 3 plus 2 over, well, do I need these parentheses anymore? No, since there's subtraction here, I can just drop the parentheses. So it's really just x plus 1 minus 4, which is x minus 3, right? The 1 and negative 4 make negative 3. And I can combine my 3 and my 2 to make plus 5. So there we go. Just like that. And I could see if I could factor to simplify, but I can't factor here, so I'm good. All right, so I'm just replacing what's ever in for x with what's ever in the parentheses, my f of whatever. And you might see it with different letters, right? It doesn't always have to have the name f for the function, okay? You might have a function called g. You might have a function called h. You might even say this function's called c, and it's made up of y's. I don't know, it could be anything. Okay, that would just mean your expression on the other side would be made up of y's instead. That's all it is. Okay, we're just naming the functions and so on and so forth. Okay, you're going to see some on your assignment like this. Let's just take a look on how you'll do this. So for example, A, it says f of 13. Well, let's think about it. So it's always f of x, right? And f of x really just equals our y, correct? So this basically says when x is 13, what is your y? Well, let's go take a look. I go to 13 on my x-axis, and I look up. It'd be right here. So that is at 18. So the y is 18. So this really equals 18. So then on your assignment, there's something I think you'd go and find wherever 18 is, and you'd put the letter A there. Okay, so you got to do that as you go. Let's do one that's a little more complicated. What about something like this guy right here for D? Well, I'd have to first do f of 3. So I got to find where x is 3. So that would be right here, and I got to go up, and that looks like it's at 8. So f of 3 is really 8, and I got to add that to 11, over, it's the square root of f of 3 plus 1. So this is really f of 4, and what is the f of 4? I just find where x is 4. I'm going to use blue here. So here's x is 4. I go up. That looks like it's right at 16. So f of 4 is really 16. So I just replace f of 3 plus 1 or f of 4 with 16. And now I simplify. So up top I got 8 plus 11, which is 19, over square root of 16, which is 4, which equals, oh, it's not quite 5. It's what, 4.75? If that answer is not on your key, I must have goofed, right? Take a look. It could have also been, the f of 3 could have been 9 as well, right? Up there. That one's kind of hard to see. So that's probably what it is. So it's probably 5. So I'm just looking for 5, and wherever there's a 5, I'm going to put a letter D down there. All right. The only other thing that might get confusing is when you get something like F. And let's just take a look at F really quick here. So now it's saying x when f of x plus 1 is 26. Oh boy. Okay, so first of all, we got f of x is equaling 26, right? And then we're saying that this is kind of going in for that x there. Well, first, what do we want to find? Where y is what? 26, right? Because really we're saying y equals 26. Well, where can I find that? Let's see. 26 is up here. So right there. Well, what is my x at that point? That would be at 6. So my x is 6. So is that my answer, 6? No, f of 6 is 26. So if I look in here, how would I make that 6? What would I put in for x? Yeah, 5. So x is really 5 in this case, right? Because f of 6 equals 26. So f of 5 plus 1 equals 26. And that's what we're looking for, was that 5, right? Because that's what I asked right here. So that one's kind of confusing. So you might have to just slow down and think through it and take your time there. And like I said, you'd find where 5 is at. Oh, so maybe I was right. Maybe double check. Maybe this guy is 4.75. Maybe I was right with that 19. I might go back and put that up there. Hey, geez, I should have some confidence in myself. So I'd find where 5 is at, and I'd plug in the letter F. Okay, so on and so forth. So there you go. Just make sure you check your work as you go. And, yeah, if you have any questions, don't be afraid to ask. It gets a little tricky by the end of it.